An important contribution to healthy crop development is using healthy soil. Soil health is the foundation for efficient farming. Therefore, fertile soil is required to develop healthy and bountiful crops. Physical and chemical characteristics are determinants when evaluating the quality of soil. There are many traits we desire in our soil, including, but not limited to, good soil tilth, depth, sufficient nutrients, small population of plant pathogens and pests, good soil, and drainage. Chemical components of soil include macronutrients, for instance, nitrogen, phosphorus, and potassium, but not excluding nutrients that are needed in small amounts, including boron and manganese. All these aspects determine the health and quality of soil, which affect the overall crop yield. In soil, a physical trait that cannot be changed is the texture. Soil texture is a trait that must be determined and dealt with while working with soil. Soil can range between clay, sand, and even silt. These three terms describe the soil's particle size. Sand is rounder and larger, while silt and clay are thinner, smaller, and flatter. All these traits factor into the airspace between the particles, which can determine aeration. Aeration is important because too much space leads to an inability to hold water. Good soil has about 50% soil volume as pore space filled with air and water. Another important physical trait is the amount of water-stable aggregates in the soil. Soils with low aggregate stability can hurt crops because surface crusts can form, making the soil hard to penetrate by water, air, roots, and important life forms. We desire biological activity to increase mineral cycling and crowding out unwanted pests. Adding organic matter can help with aggregates in the soil and improve water holding capacity of the soil. Organic matter may only make up 6% of the soil, but it can have a large impact on multiple important characteristics of the soil.
Our design objective was to design a device to determine the profile of the soil and then fix it. We generated ideas and determined that we should first find a way to take soil samples in order to take measurements of various properties. When the samples are collected on the board computer, we'll average the values and determine the soil composition, allowing for proper readjustment of the soil levels by increasing or decreasing the appropriate chemicals. Our goal is to fix the soil by changing the composition to the desired composition that would be best for whatever crop that would be grown on that land. The wheel will be rolled on the soil. As it turns, the spikes will enter the soil and the sensors will take multiple measurements and take an average. Any deviation from the desired composition will cause the pores in the wheel to open and allow the correct amount of material from our tank to pour into the soil. The spike will turn and the soil will be mixed along with the new material. We designed for safety by adding a large frame around the spiked wheel to act as a barrier from humans who may approach it. We minimized our cost by only using the minimum amount of sensors required for accurate measurements. The impact on the society and environment is that by maximizing soil usage and materials used to improve the soil, we maximize crop output and minimize harmful elements that end up in the environment.
The design for our device takes into account the design objectives and customer requirements. Our design objectives include determine the soil composition and fix the soil to desired levels. Our customers include those who work with agriculture, for instance, those involved with crop cultivation. Some of the customers' requirements include ease of operation, durability, compatible with existing tractor models, override capability, high performance, low total cost of ownership, and low maintenance.